Hi everyone. So now we're going to talk about how to graph linear inequalities. And linear inequalities are just equations or inequalities that have an x and a y, but instead of having an equal sign, they have a greater than or a less than or greater than equal to, less than or equal to sign. Um, so we graph them very similarly to how we graph linear equations. The only difference is that we just have a couple of extra rules. So let's go over some of those extra rules really fast, then we'll go through some examples. Um, so the first rule is that sometimes we have dotted lines. We have to use dotted lines when we graph them, and then sometimes we use solid lines. And we use dotted lines when we have a less than sign or a greater than sign. In comparison, we have a solid line when we have a less than or equal to sign or a greater than or equal to sign. And then the other extra rule is where it's shaded. So when we graph linear inequalities, there's a portion of it that's shaded. The reason why we shade these linear inequalities is because when I tell you, like for example, if I told you that x was less than 5, then x potentially could be 4, it could be 3, it could be 2, it could be 1, it could be negative, which means that we have to shade all of the possible options when we're graphing. Okay, so when we're shading, we shade above when it's y is greater than or y is greater than or equal to. And then we shade below when it's y is less than or y is less than or equal to. And when I say shade above and shade below, I mean shade above the line and then shade below the line. So we have to draw the line first and then we get to shade it. Okay, let's go through some examples. So the first example we have is y is less than or equal to 2x plus 4. All right, so what I'm going to do is treat this like a normal equation, and I'm going to find the slope and the y-intercept. So my y-intercept is 4, and then my slope is 2, just based on that y equals mx plus b form. So I'm going to start with my y-intercept, which is 4, and graph that on the y-intercept, on the y-axis. And then my slope is 2, which means that I can write that as like 2 over 1. So the rise over 1 comes into play. So I would go up 2 and over 1. I could even go down 2 and backwards 1 just to create that same line. Now this is y is less than or equal to. So based on our rules from up here, when it has that extra equals to sign, that means we're using a solid line. So I'm going to do it in green. Okay, so this is my solid line to represent that it's less than or equal to. And then because it says less than or equal to, I'm going to shade below this graph or below this line, and you can really just kind of go like that. And what that tells us is that anything that I just shaded is a potential solution to the equation or the inequality. Okay, let's go through another example. Okay, so this one, let's do y is greater than negative 1/3 x minus 2. Okay, so once again, we're going to start it like what we would normally do with just a regular equation. We're going to find the y-intercept, which is negative 2, and then our slope, which is negative 1/3. Okay, so I'm going to start with my y-intercept, put that negative 2 on that y-axis. Then my slope is negative 1/3, which means that's my rise over run. And remember, the negative attaches itself to the rise, which means that I'm going to go down 1 and then over 3. I could also go backwards. I could go up 1 and backwards 3 just to keep that line going in the opposite direction as well. So now we're going to go back to our rules. I'm going to scroll up here a little bit. We know that our example is a greater than sign. So the greater than sign is in the dotted section of the dotted versus solid, and it's in the shade above section of the shade above or below. So we're going to start by dotting this line, and honestly, all I do is just draw a line but make it dotted, just like that. And then because it's y is greater than, we shade above, which means I'm just going to kind of shade that section above there, which represents, again, all of the solutions that it could potentially be. All right, so those are pretty easy because they're in that slope-intercept form. Now let's go through a couple that are in standard form. So the first one we're going to do in standard form is 2x minus 4y is greater than or equal to 12. Now, here's the deal. The last time we were converting between or graphing standard form equations, I told you could use either the intercept rule or you could use just converting it to slope-intercept form. And while both of those still basically work, I would prefer you, or it would most likely be easier to just solve all of these to be in slope-intercept form. And the reason why is because with inequalities, if you ever have to divide by a negative number, the inequality flips. And sometimes we don't recognize that when we're just trying to find intercepts. So, and it's going to happen here. So let me just show you this example. So the goal here is to get y by itself to get it into that slope-intercept form. So the first thing I'm going to do is subtract the 2x from each side. So now I have negative 4y is greater than or equal to negative 2x plus 12. Okay, so I want to get rid of the y, which means I've got to get rid of this negative 4. So I'm going to divide everything by negative 4. And like what I just said, if you ever divide in an inequality, if you ever have to divide by a negative number, you have to flip the inequality sign. So while this stays, this is y, and then the negative 2 divided by negative 4 gives me 1/2. And 12 divided by negative 4 gives me negative 3. Everything stays the same right there. Instead of the greater than or equals than sign in between, now it's going to be less than or equals than because I had to divide by a negative. And so this is my slope-intercept form, which now from here I can say, well, my b is negative 3, my m is 1/2, and now I can graph this sucker. So y-intercept is negative 3. I'm going to put a point on my y-axis as negative 3. My slope is 1/2, which means I rise 1 and run 2. So I'm going to go up 1, over 2. I could go up 1 and over 2 again. Down 1, backwards 2, you can do whatever you want, as long as you have 2 points that you can connect. You can have more points, though, as well. And then based on the rules from above, we have a less than or equals to sign. Because of that extra equals to, we know that it's going to be a solid line. Sorry, I should make that a little bit darker. Okay, and then because it's less than, we shade below. And there we go. All right, let's go just through one more example. Let's see, so this time I want 3x plus 2y is less than 10. Okay, so once again, we're going to convert this to slope-intercept form. So we're going to subtract 3x from each side. We get 2y less than negative 3x plus 10. Then we want to get y by itself, so we're going to divide both sides by 2. This time, because we're dividing by a positive number, the inequality does not switch, so it'll stay that less than. So this 2y divided by 2 just gives me y. Negative 3 divided by 2 won't simplify, so we're just going to leave it as negative 3 over 2x. And then 10 divided by 2 gives me 5. So here's my slope-intercept form of the inequality. So that means my b, or my y-intercept, has to be 5, and then my m, or my slope, has to be negative 3 over 2. All right, let's graph this sucker. So we're going to start with y-intercept, which is 5. We're going to find 5 on the y-axis and put a point there. My slope is negative 3 over 2, which means my rise is negative 3 because the negative attaches itself to the rise. So my rise is negative 3, and then my run is 2, which means I'm going to go down 3 and over 2. Oh, sorry, let me just erase that. Okay. I could go down another 3 and over 2, but like I said, you only really need 2 points. So now we have to decide, is the line going to be a solid or dotted line? In this case, because it's just less than, it's not a less than or equal to, it's a dotted line. And then because it's less than, it is shaded below. So there we have it. And this is how you graph